Good day, ma'am. Presenting to you the output of Group 3 for the Assignment 5 entitled Knowing About Probability Samples. So the example that was given to us entails that a researcher wants to find out about the lunchtime eating habits of workers in a particular car factory. She obtains a list of all employees, chooses a starting number, chooses an interval number, and then works through the list, developing her sample list from the employees that appear at the correct interval on the list. The first task to do is to name the sampling technique. So based on an example that was provided to our group, it definitely shows that this kind of research employed a systematic sampling technique. We can state that it applies a systematic sampling due to the fact that the handed example to us clearly possesses the process of a systematic sampling technique, particularly when the researcher obtained a list of the employees that are significant to her study, when she chooses a starting number and applied a periodic interval. Therefore, this is an example of a systematic sampling technique, considering that this kind of sampling refers to a sort of probability sampling in which individuals of a bigger population are chosen at a random from a larger population by a fixed periodic interval. This interval is also known as the sampling interval and is computed by dividing the population size by the sample size desired. Despite the fact that the sample population is chosen in advance, systematic sampling is still considered random if the periodic interval is set in advance and the starting point is chosen at random. The next task to do is to highlight possible strengths and weaknesses of systematic sampling technique. So in terms of its strengths, systematic samples are simple to create, run, compare, and comprehend. This is especially significant when conducting studies or surveys on a limited budget. A systematic approach also gives statisticians and researchers a sense of control and procedure. If the sampling is suitably built to fit certain parameters, this could be especially useful for investigations with precise parameters or a narrowly formulated hypothesis. The results of systematic sampling are credibly appropriate. The statistical method's outcomes are more efficient and appropriate when compared to other statistical approaches. The chances of data manipulation are extremely minimal, and the systematic sampling method carries only the tiniest bit of risk. And due to its structure, researchers may quickly create, evaluate, and conduct samples when utilizing this method. When researchers use systematic sampling, they can rapidly and easily represent an entire population. Because the purpose is to provide representative data of the entire group without unique individualized identification, there is no need to number each member of the sample. The samples obtained by systematic sampling are more precise than those created by other randomized approaches. Also, it lowers the risk of data bias. This is by the fact that the selection procedure is at a set distance between each participant. Systematic sampling processes provide an advantage here. Also, favoritism is less likely to occur. Researchers have no say in who is chosen for systematic sampling, which provides the advantages of randomized selection while also protecting data collection efforts from favoritism. Now, in terms of its weaknesses, a close approximation of a population is required for this operation. If that amount is not accessible, the selection for procedure will fail since the size of the pool pooled for participation is determined by the division of the total figure. When a smaller demographic group is being studied, some individuals may notice that systematic sampling approach. When this advantage arises, the population may be skewed since non-participants will be different from those who are able to participate. It may inspire some people to give fraudulent responses in order to sway the results for personal gain, thereby working against the theory under investigation. The systematic sampling method generates fractional chances for selection, not an equal chance. There is no way for people's perspectives to be included in the collected data if they fall between the numbering system and their count. In some demographics and groups, the process of selection in systematic sampling might unintentionally interact with concealed periodic features. If this problem arose at random through the integer selection process, the sampling technique would match the trait's periodicity. That means the final dataset would not be a random sample of the entire group because the periodic attribute would be overemphasized. The next task is to give another example or research project that could utilize this particular sampling technique. So, here are some examples and at the same time the steps in performing systematic sampling technique. So, step 1 is to assign a numerical value to each member of your population. Let's pretend you have a population of 100 persons and you want to assign the numbers 1 to 100 to the group. So, the step 2 is to determine the appropriate sample size. Look up sample size. So, let's imagine you require a sample of 10 persons for this example. So, the step 3 is to divide the population by the number of people in your sample. So, if your population is 100 and your sample size is 10, so you'll need to do the following. So, 100 divided by 10 is equals to 10. So, this is your end sampling digit. So, every 10th item will be chosen. So, this is how you perform a systematic sampling technique. So, here's another example. So, if you wanted to select a random group of 1,000 people from a population of 50,000 people using systematic sampling, you would need to compile a list of all potential participants and choose a beginning point. Following the formation of the list, every 50th individual on the list, counting from the designated starting point, would be picked as a participant because 50,000 divided by 1,000 is equals to 50. So that will be all. Thank you.